Hi guys, I'm Anand Chaudhary, and today I'm coming back to you guys with a new video. The derivative of exponential functions. So why don't we head on into it? So there are two new formulas I want to introduce to you before I head on into the problems. The derivative of e to the power of x is equal to e to the power of x, and the derivative of ln x is equal to 1 by x. Now these are, again, formulas that you should memorize by heart so that you're able to solve problems like those a lot easier. So why don't we head on into these using these formulas. First problem we have, y is equal to e to the x plus 9. Now, you could do this by using chain rule. So what we're going to do is we're going to use this formula over here. So I'm going to do dy dx is equal to e. Now the derivative of anything of e to the power of something would be e to the power of whatever that is. So e to the power of 7x plus 9, but since this is not x, I'm going to have to apply the chain rule and multiply by the derivative of that. Now using power rule, the ddx of 7x plus 9 would just be 7. So dy dx is equal to 7 e to the power of 7x plus 9. Very simple problem. Okay. Second problem, y is equal to e to the x cubed. Interesting problem over here, but nothing we can't solve with that formula right there. So we have to find the derivative. So dy dx is equal to e to the x cubed. Why? Because of this formula. Anything that is to the power of, anything to the power of anything that e is to the power of will stay there, but you're just going to have to apply chain rule. And using power rule over there, we can say that this is 3x squared. And remember, chain rule says you have to take the derivative of whatever that is. So, dy dx is equal to 3x squared e to the x cubed. Box that answer, and I should box this one too. Okay. Problem number 3. It's another sort of problem like this, except a little bit more of a complicated function on top. So we have y is equal to e to the x cubed plus 9x. What are we going to do over here? We're going to do the exact same thing we did for the other two problems. dy dx is equal to e to the x cubed plus 9x times the derivative of that. Derivative would say 3x squared plus 9. Plus 9. So then dy dx is equal to 3x squared plus 9 times e to the x cubed plus 9x. That 3 is a little messy. 3. Now you can simplify that more if you want by distributing the e in, but for the sake of this video, I'll keep that a little short. But now here we have a problem where we have a constant in the base of the x, in the base of the power. So what we're going to do is we're going to actually take the log of both sides so that we are able to, you'll see. So we're going to take, before we take the derivative of this, ln y times ln 7 to the power of 2x plus 1. Now what does this do for us? Now using the logarithmic properties that we know, we can take this down here. So ln y is equal to 2x plus 1 ln 7. Now we can take the derivative using this formula right over here that we learned. ddx of ln x is equal to 1 by x. So if you were to take the derivative, so I'll just write it over here, ddx of ln y is equal to ddx of 2x plus 1 times ln 7. ln 7 is a constant, so we can take that out of the derivative section. We can move that over there. So taking the derivative of this would be 1 by y, using this formula. But remember, since this is a y term, this is part of the implicit differentiation we learned a couple of videos ago. We're going to have to multiply dy dx. dy dx. And this would equal to ln 7 times the derivative of 2x plus 1 is 2, using power rule, is equal to 2. So dy dx, if you multiply y by both sides, you're going to get 2 ln 7 times y. So it's 2 ln 7 times y. And yeah, that's your final answer for the derivative of this. And these are like some of the type of trick problems that you might get in a few tests. And it's very important to know how to take logs and stuff so you're able to simplify and be able to find the derivative of this. Thank you for watching. I hope you guys learned something new today, and subscribe if you haven't already. Leave feedback in the comments for what I can improve on in these videos, and thank you guys for watching.